You know that feeling you get sometimes? That nagging uncertainty about some complex system you really rely on?
Mhm.
Maybe it's just your home Wi-Fi, or I don't know, a garden you spent ages planning, or even a big online service you use every single day?
Yeah, you know it's mostly working.
Mostly, exactly.
Yeah.
But do you really know what's going on under the hood? Like, what if one little part, maybe a tiny root in that garden, is struggling? Or uh, a key digital bit is silently about to fail?
It's that feeling of flying blind, isn't it? And knowing what's actually happening or what might happen, well, that's just critical for reliability, especially with these, complex distributed systems.
It really is. And that's exactly what we're diving into today. We're trying to understand the, let's call them vital signs, of a seriously complex digital system, a Kubernetes cluster.
Okay.
Now, for those who know, Kubernetes is basically this big system for managing potentially hundreds, even thousands, of application parts. They call them pods, running across a bunch of machines or nodes, all talking through services. It gets complicated fast.
It really does.
And you've shared some great sources that dig into three specific tools: Prometheus, Grafana, and metric server. Seems like these are, well, pretty much essential for anyone running these kinds of setups.
Yeah, they're kind of the indispensable eyes and ears, really. They're designed to bring clarity to what can often feel like a constantly shifting digital
Yeah,
landscape.
right. So our mission today for this deep dive is to unpack what each one does, why you absolutely need them for performance and, keeping things running smoothly in Kubernetes.
And how they work together.
Exactly, how they collaborate to give you that clear picture of your cluster's health. The aim is, by the end of this, for you, the listener, to walk away with a kind of shortcut, feeling pretty well informed about Kubernetes monitoring.
Hmm.
I mean, if we think about it simply, monitoring is really just checking the vital signs of your Kubernetes cluster, right? Like a doctor checking a patient.
That's a great analogy, actually. And if we stretch it a bit, Prometheus, that's like the nurse, maybe. The one who tirelessly collects all the data points, heart rate, temperature, that sort of thing from every part of the cluster. Never misses a beat.
Okay, I like that. Prometheus is the nurse collecting data. So where does Grafana fit in?
Grafana then is like the monitor screen next to the bed. It takes all that data Prometheus collected and displays it really clearly, colorful charts, graphs, so you can see trends and issues at a glance.
Makes sense, visualizing the data. And the third one, metrics server. What's its role in this health monitoring team?
Ah, metric server. Think of that as your quick check tool. It grabs just the basic immediate stats needed for, well, for crucial real-time things. Often it's for auto scaling, making sure applications can respond instantly without someone having to jump in.
Got it. A quick check for immediate needs. So we've got the analogy, but what makes monitoring Kubernetes specifically so tricky?
Hmm.
Your sources really hammered this point.
Mm.
These clusters aren't just complex, they're incredibly dynamic. Pods spinning up,
Yeah.
scaling, disappearing, sometimes in seconds.
That's the absolute core of it. Old school monitoring tools often struggle because they expect things to stay put, static targets.
Right.
The real power of Prometheus, Grafana, and metric server is how they're built from the ground up specifically to track these moving targets. They give you a live, adaptable view of this constantly churning environment.
Okay.
Take Prometheus, for example. It's open source, a monitoring and alerting toolkit basically designed for this world. It pulls in and stores time series metrics, things like CPU load, request times, memory usage from everything in your Kubernetes setup, your applications too.
Time series data. So data points stamped with the time.
Exactly. And that's incredibly powerful. It means you don't just see what's happening right now. You can analyze trends over time, maybe predict future problems, or even zoom in on the precise moment something started going wrong. It's designed to scrape metrics, pull them from various places, and it has really strong tools for querying that data and setting up alerts.
Okay, so it's not just grabbing numbers, it's building that historical context.
Yeah.
That sounds super valuable for figuring things out. And then Grafana slots in. Your sources mentioned it's a visualization platform, works right alongside Prometheus.
Mm-hmm.
It turns all that raw, timestamp data into those interactive dashboards you mentioned, graphs, charts, tables, making it easier to actually understand what you're looking at.
Precisely. If Prometheus is the collector and the library, Grafana is the skilled interpreter making sense of it all visually. It transforms raw numbers into actionable insights.
And metric server, you said it's different.
Yeah, quite different in its job. It's lightweight, runs right inside the cluster. Its whole purpose is to collect resource usage metrics, specifically CPU and memory from the nodes and pods.
Just CPU and memory?
Primarily, yes. Because that data is critical for core Kubernetes functions, especially one called the Horizontal Pod Autoscaler, or HPA.
Ah, the autoscaler.
Right. What makes Metrics Server special is that it provides this lightweight, real-time snapshot. It only keeps the data in memory for a very short time. It's not for digging through history, it's for what's happening right now. And that immediate focus data is exactly what the HPA needs to make quick, automatic scaling decisions to keep your apps responsive.
Okay, that distinction is really important. So, metric server for the quick, right now, CPU and memory checks to drive automated scaling,
Correct.
while Prometheus is gathering a much richer set of historical data, which Grafana then helps us visualize for things like application latency, error rates, spotting longer-term bottlenecks.
You got it. Those are some pretty powerful capabilities when you put them all together.
They really are. And thinking about why these are so indispensable, the sources kept stressing that Kubernetes clusters just have so many moving parts, pods, nodes, services. Any one of them can fail or just, slow down, often without any obvious warning signs.
Exactly. And without tools like these three, you're basically operating in the dark. They give you that vital, fine-grained visibility into how your cluster and your applications are actually doing. Let you be proactive about spotting issues and optimizing performance.
Proactive issue detection, that sounds like a game changer. Prometheus, you mentioned alerts. So it can flag things like high CPU or pods failing before users even notice.
That's the goal, yes. Its alerting capabilities are really powerful, and that's often the difference between, say, a minor hiccup your team fixes quietly behind the scenes and a full-blown outage hitting your customers.
Yeah, nobody wants that.
Definitely not. And Grafana's visual side is invaluable there, too. The dashboards make it so much easier to see trends and patterns. Maybe it's traffic spikes causing saturation, or perhaps a slow memory leak that's gradually eating up resources. Seeing it visually just simplifies troubleshooting and finding the root cause so much.
And the auto-scaling part from metric server that seems incredibly practical. You mentioned the HPA. So it feeds the real-time CPU and memory stats straight to the Kubernetes system itself.
Directly to the Kubernetes API, yes, which lets features like the HPA automatically scale your applications up or down based on the actual demand at that moment. Think about an online store during a huge flash sale.
Right. You definitely don't want someone manually trying to add more servers in the middle of that chaos.
Absolutely not. It needs to be automatic and instant. These tools also let you monitor custom things, specific metrics about your own application's performance, not just the cluster infrastructure. Gives you really deep insights.
Plus, it sounds like it just makes life easier for the operations teams. Automating the monitoring, reducing manual checks.
Oh, massively. Especially when you're managing large dynamic clusters, it boosts operational efficiency significantly.
Okay, it really sounds like these tools are pretty much non-negotiable if you're serious about running Kubernetes. What happens if a team decides not to implement this kind of robust monitoring? What are the sort of hidden costs or real-world problems they'd face?
Well, like we said, you'd be relying on maybe manual checks, digging through basic logs. It just makes it incredibly difficult to spot problems quickly, or even just to understand how well your cluster is performing overall.
So things could break without you knowing for a while.
Exactly. You could have undetected failures just lingering. You might be wasting money by over-provisioning resources because you don't know what you actually need, or the opposite, under-provisioning and causing slowdowns. And crucially, you wouldn't be able to scale dynamically with demand.
And the bottom line there is,
The real-world consequences are pretty significant. Downtime, which costs money and frustrates users, a generally poor user experience, and ultimately, loss of revenue or customer trust.
okay, let's make that really concrete. Let's go back to that online store example. Peak holiday season, stores running on Kubernetes. How do these three tools work together right then?
Okay, good example. So Prometheus is constantly running, scraping metrics maybe every 15 or 30 seconds. It's collecting things like CPU and memory usage from every single pod, maybe database connection pool sizes, and even application-specific things like how long checkouts are taking.
Okay, gathering all that detail.
Meanwhile, Grafana has dashboards set up, pulling data from Prometheus. Your team is watching live traffic trends, maybe conversion rates, the health status of all the different backend microservices, all visualized clearly.
Right, and the metric server.
Metric server is humming along too, specifically feeding the current CPU and memory usage for those checkout pods straight to the Kubernetes API.
Just the current stats.
Just the current stats. And that's what the horizontal pod autoscaler, the HPA, is watching like a hawk. So if a sudden rush of shoppers hits and the CPU usage on those checkout pods jumps past, let's say, 70%, The HPA, using that fresh data from metric server, automatically tells Kubernetes, we need more checkout pods now, and Kubernetes starts spinning them up.
Okay, so more pods appear automatically.
Yep, and as soon as they're up, Prometheus discovers them because it's watching Kubernetes and starts scraping their metrics too.
Ah, okay.
Grafana's dashboards update automatically, showing the increased pod count and hopefully the CPU usage stabilizing back down. The whole thing keeps the checkout process smooth for customers, even during the rush. It's like a seamless, self-healing operation.
Wow, okay. That really shows how they work together, all powered by these three tools working in concert.
It's a perfect illustration. So we understand their individual roles, but how do they technically come together as this health monitoring team? The sources explain this collaboration pretty well.
Right, the data flow.
Yeah, Prometheus, Grafana, and Metric Server work together to collect, store, and then visualize the metrics. Prometheus grabs the detailed historical stuff.
Hmm.
Metric Server handles that lightweight, real-time resource data, and Grafana makes it all visible.
Okay, so tracing the data. Metric server runs as a pod inside the cluster, right?
Correct. It collects CPU and memory from nodes and pods, usually through the Kubernetes API itself. And the key thing for its specific job is it stores this data only in memory, just for short-term use. It's not built for long-term analysis.
Right, it's for immediate action, like that HPA example.
Exactly. So Metric Server provides the current CPU load for your web app pods, enabling the HPA to scale them up right then if usage spikes past that 70% threshold, for instance. It's crucial for that instantaneous automated response.
Got it. Then, next in the chain, Prometheus, also running as a pod.
Usually, yes. It also runs as a pod, or maybe a set of pods. And it's the one doing the heavy lifting for persistent metrics. It actively goes out and pulls or scrapes data from configured targets. These could be other pods, the nodes themselves, applications that expose their metrics, usually over HTTP on a specific path, like metrics.
Yeah, it fetches the data.
It fetches the data, stores it as that time series data we talked about, building up the historical record, and it also handles the querying and the alerting based on that data.
So for our online store's complex microservice, Prometheus might hit its metrics endpoint every 15 seconds, grabbing request counts, error rates, response times.
Precisely. It's the robust, persistent data collector building that long-term picture of performance and health.
And finally, Grafana brings it all to life for the humans involved. It can run inside the cluster or outside, you said.
Yeah, it can be deployed either way. And its key function here is connecting directly to Prometheus as a data source.
Ah, okay.
That connection lets you build those custom interactive dashboards, pulling data from Prometheus and displaying it in graphs, charts, gauges, whatever makes sense.
This is where the team actually goes to see what's happening, analyze trends over time, or check performance right now.
Exactly. For example, a Grafana dashboard could show a graph of the average customer checkout time over the last 7 days. You'd clearly see any spikes, maybe correlate them with peak traffic times or a recent software deployment, helping you pinpoint if something introduced a bottleneck.
Okay. And how tightly do they integrate with Kubernetes itself? Metric Server obviously talks to the API for HPA.
Right. Metric Server is tightly integrated with the core Kubernetes API for those resource metrics. Prometheus, on the other hand, cleverly uses Kubernetes' built-in service discovery.
Service discovery.
Yeah, it means Prometheus can automatically find new things to monitor, like new pods or services as soon as they appear in the cluster, and stop monitoring them when they disappear. It doesn't need manual configuration every time something scales up or down.
That's pretty smart. Keeps up with the dynamic nature.
It has to. And Grafana.
Right.
It mainly just needs to know where Prometheus is so it can query it for the data it needs to display.
Okay. And the last piece is acting on this data, the alerting.
Critical piece. Prometheus has a sophisticated alerting component. You define rules like, if pod memory usage stays above 90% for 5 minutes, fire an alert. It can then notify teams through various channels, email, Slack, PagerDuty, whatever they use.
So the alert fires.
Right. Metric server data, as we said, directly drives the auto-scaling. And Grafana dashboards are what the team uses to investigate when an alert does fire. They jump into Grafana, see the visual context of the problem, and figure out what's going on much faster.
So that alert, about 90% memory usage fires from Prometheus. You click the link in the alert, jump straight into a pre-configured Grafana dashboard showing that pod's memory trend, maybe related application logs or other metrics.
Exactly. You can quickly see the trend, maybe identify which process inside the pod is responsible, figure out the root cause, and take action before it causes a major problem. It's a really cohesive, proactive system when set up well.
Okay, yeah, that really paints the picture.
So in short, Prometheus, Grafana, and Metric Server really are that essential health monitoring team for Kubernetes. You've got Metric Server grabbing those quick snapshots of resource use,
Yeah.
Prometheus collecting all the detailed historical stats and handling the critical alert, like warning you if that crucial payment pod's memory goes over 90%.
And Grafana showing it all in those easy-to-read, actionable charts.
Exactly. And together, they help you keep your cluster humming along smoothly, spotting issues early, enabling smart auto-scaling, and just giving you clear insights so you understand the why behind your cluster's performance or problems.
And just to reiterate why this matters so much, Kubernetes clusters, they're complex, right? Lots of moving parts, pods, nodes, services, any of which can fail or just underperform.
Yep. And without these kinds of monitoring tools, you really are back to manual checks, maybe some basic logs.
Hmm.
It's just incredibly hard to detect issues quickly or really understand performance, especially at scale.
And that, as we talked about, can easily lead to those undetected failures, wasting resources, not being able to scale when you need to.
Which ultimately means downtime, unhappy users, lost revenue. It's a big deal.
So we've seen how they act as this cohesive team. Metric Server does the quick, real-time resource snapshots.
Prometheus collects the detailed history and fires off those critical alerts, like that 90% memory warning for your vital payment processing pod.
And Grafana, with its clear charts, helps your team instantly see what's going on, identify the cause, and react effectively.
Understanding these tools, it isn't just for the hardcore IT pros. It's really about appreciating how the digital world we all rely on day in and day out actually stays stable and performs well.
That's a great point.
Whether it's that online store scaling perfectly during a crazy sale or, your favorite streaming service delivering your show without a single stutter, this kind of underlying monitoring is absolutely key to making that seamless experience happen.
It really is the unsung hero behind so much of our digital lives, which actually brings us nicely to our final provocative thought for you, the listener, to maybe mull over. If these tools, Prometheus, Grafana, Metric Server, are like checking the vital signs of a complex machine like Kubernetes, what kind of vital signs are we perhaps not yet monitoring effectively in other complex systems?
Interesting question.
Yeah, think about systems like, I don't know, environmental ones or social systems, maybe even our own personal health and well-being sometimes. What crucial data points out there could unlock completely new insights if only we had the right kind of Prometheus to collect the data, the right metric server for the immediate stuff, and the right Grafana to help us visualize and understand it all?